Now students, we'll discuss third application of Gauss theorem. Look at students, electric field due to uniformly charged spherical cell. Spherical shell means hollow sphere. We are having a hollow sphere, it is charged, okay, and we have to find electric field due to this charged hollow sphere, spherical shell. So let's start. See students, this is the hollow sphere, this one, having radius capital R, center O, okay, and it is charged, it is uniformly charged. The property of hollow sphere is when you provide charge, all the charge uniformly distribute on its outer surface. Look at students, on its outer surface, okay. So Gauss theorem is always applicable when charge comes in closed surface, okay. So we have to assume a spherical closed surface around this hollow sphere, and this closed surface is said to be Gaussian surface, okay. This closed loop is said to be Gaussian surface around spherical shell. So outer one is the Gaussian surface and this is spherical shell. Now students, when charge comes in closed surface, it releases electrical flux. And how much flux will release? That is phi equals to closed integration of E dot ds. That flux will release from this closed surface. Actually, we'll find electric field at 3 points. First of all, we'll find electric field when P lies outside the sphere. Look at, this is a sphere with radius R. From the center, at certain distance r, small r, at particular point P, we'll find electric field. Now P lies outside the sphere. Okay students. So now students, when you remove dot, there come cos theta. This is the partial area, and area, we know the direction of area, it is normal to the surface. So this is the direct normal to the surface, this is the direction of area, and when we put there a test charge plus repel that test charge, so this will be the direction of electric field. What we found, E and ds are in same direction, so theta should be 0 and cos 0 1. So cos 0 1, E comes outside from integration, and integration of ds. Integration ds means what? Surface area of this Gaussian surface, that is a sphere, and we know the surface area of a sphere is what? 4 pi r square, okay, because small r is the distance of Gaussian surface, is the radius of Gaussian surface, okay. So this is the flux that released from Gaussian surface. Now students, again we are applying Gauss theorem. We know phi equals to q by epsilon naught, and we compare both. Comparing equation second and third, when left hand side equal, right hand will also equal. So E into 4 pi r square will equals to q by epsilon naught. 4 pi comes in denominator, 4 pi epsilon naught, q as it is, r square, it comes in denominator. So you'll get E equals to 1 upon 4 pi epsilon naught q by r square. And students, 1 upon 4 pi epsilon naught, that is electrostatics constant. So finally we can write E equals to k q by r square outside the sphere. So how much electric field generate outside the sphere when P lies outside the sphere? Kq by r square. Now students, we'll find electric field when P lies on the surface. We did in first case when P lies outside the sphere. Look students, when P, this is our hollow sphere, that is a hollow sphere, it is charged, all the charge uniformly distributes on its outer surface, and this time P lies on the surface. So O to P, that distance becomes small r. In first case, P was outside, now P comes on this point at surface. So Gaussian surface will make along with the hollow sphere, along with the hollow sphere. Now students, how much electric field generate when P is outside? We found just before kq by r square. E out. For getting electric field on the surface at point P, for surface distance will equals to radius of a sphere. Small r equals to capital R. Small r is the distance and capital R is the radius of a hollow sphere. So we'll make a small change. Instead small r, we'll put capital R. So it become ES, electric field on the surface, KQ by capital R square. So for outside, that is KQ by small r square, small r is distance. And for surface, KQ by capital R square. Capital R square is the radius of a. Now students will find finally electric field inside the hollow sphere. That was the first case, outside the sphere, on the surface. Now we'll find inside the sphere. When P comes inside, okay, this will assume as Gaussian surface. This time Gaussian surface will make inside the hollow sphere. So outer one is the hollow sphere and this is the Gaussian surface. Okay, the important thing is in hollow sphere, all the charge is uniformly distributed on its outer surface. Inside there will be no charge. Inside charge is 0. When charge 0, then flux 0, and when there is no charge, it will not release any flux, and electric field inside the hollow sphere should be 0. So electric field inside the hollow sphere should be 0 due to absence of charge.